Inclined planes can be as simple as this ramp. They can be the threads of a screw. They can be the wedge of a log splitter. But all of them provide some sort of mechanical advantage or redirection of the force. In this lab, we're going to use an inclined plane and determine its ideal and actual mechanical advantage. Here's what you need. For this lab, you're going to need a piece of plywood, which we'll use for the inclined plane. You're going to need a ring stand with the ring on it. This is going to be used to change the amount of slope. You're going to need a cart with string so we can pull it up the inclined plane. To make the job a little easier, we have a little pulley clamp to put on the end of the board, and spring scale. And last, you're going to need a meter stick. I don't have one with me. Here's how we do it. You're going to attach the pulley clamp to the end of the board, which is the small end, right in the middle. Rest it on the ring stand. And the clamp itself, I can show you, this clamp itself will actually sit inside the ring. It kind of holds it in place so you don't have to make any adjustments. Now the key is you're going to be doing 4 different measurements, 4 different heights. So you got to take your meter stick and you're going to be doing 20, 40, 60, and 80 centimeter heights. We want you to get a good accurate reading from the bottom of the table to the tip of this board. And you do that by adjusting the ring itself. We're going to weigh the cart with the spring scale. It's like you're weighing a fish. That value goes in the entire column 3 of your data table. That's column 3. Then you take the meter stick, measure the full length of the ramp. It's more than 100 centimeters, so you got to use 2 of these. Enter that and all of the entries on column 2. Then we're ready to set up and make the measurements at each of the 4 measurements of 20, 40, 60, and 80 centimeters. That's how you do it. First measurement's going to be at 20 centimeters. Make sure the ramp's right at exactly 20 centimeters. Then set up the cart. Take the cart, put it in the center of the ramp. Take the string, run it through the pulley, and then the string goes down through the ring stand right in the middle of it. And I attach the meter to the end slowly at a constant speed and get the reading. Okay. Put the cart all the way down. Take the meter stick, go up to 40 centimeters. Again, pull very slowly, get the reading for 40 centimeters. Put the cart down, go to 60, pull very slowly, finally go up to 80, higher yet. Nice and slow, get those 4 readings, and then we do the calculations. For the observations for the inclined ramp lab, for the table, this is going to be the height of your ramp. Column 2 will be the length. So you just measure the length of the ramp and put that value, same value for all of them. And this will be in centimeters. For the resistance force, that's the amount of load you're pulling. That's the weight of the cart. So get that weight with the spring balance, put that value all 4 places. So these 2 columns have the same value throughout. And then column 4, this is the effort force. This is the force it takes to pull the cart up that ramp height. And it'll change depending on how steep the ramp is. So these all vary. Now, what do you do with these values? You go into the next part of your lab for the AMA and the IMA calculations. Let me explain the difference. IMA is the ideal mechanical advantage. That's what we should expect, the amount of force increase we should get with the tool we're using. And we'll be doing this for all of our labs. The AMA is the actual value of the advantage. The actual will always be less than the ideal because of frictions and other losses in the system. That's going to be one of your questions in the lab. So I'll first go through the IMA with you first. That's the easiest to do. All you do with that is you take your length of your ramp, okay? And I'm just going to, for my case, you're going to have to measure your own. Mine, I'll say mine's 100 centimeters. Yours is definitely longer, okay? And that'll be the same, throughout, 100 all the way down. For the IMA, the ideal, I take the ramp length, 100, divided by the height, 20, and my advantage then for that would be 5. And do that for the same for all the other ones as well. So 40 would be 100 divided by 40, and that would be, I don't know, 2.5, I guess, 2.5. Again, yours will be different. Your height that you use will be different. So do that for all 4. That's your ideal. Now the actual, this is what you actually saw as an advantage. So for that one, you're going to divide your resistance force divided by the effort force. So let's say my cart weighed 500 grams. We can pick a numbers that are just nice and easy for me. And let's say for this one, it was 100 grams. Well, 500 divided by 100. So for the actual, at the 20 centimeter height, I'd have 500 divided by 100, and it'd be 5. Now, in my example here, they're both the same number. It'd be nice if these were the same number, but this number for the IMA numbers will always be higher than the actual. So I may have gotten maybe 4 point something here for this instead. So anyway, for all these, you're going to take, again, the measurements of this mass, and this is the same throughout, divided by this force, and you divide those to get your AMAs. Answer the questions, and you're all set. The last thing we have to calculate is efficiency of the inclined plane. Efficiency just describes how well the mechanical advantage of the ramps was actually transferred into the cart as it was being pulled up, and simply achieved by taking the AMA that you've calculated for a certain height divided by the IMA of that same height. So we did it 4 times. So for 20, you'll divide the AMA of 20 divided by the AMA of 20 divided by the IMA of 20. Same for all the other ones. 40 AMA divided by the 40 IMA. And you have these percentages here. They're all going to be less than 1. So it'll be decimals. Let's say I had, like 0.8. Well, that's then 80% efficient. And they'll be different. And that'll be one of the questions I'll ask for you. Why are some higher than others? And that'll be it for the calculations. Now, last thing you got to do then is get some graph paper. We're doing this on paper. You're going to have to graph the AMA and the IMA versus the height. So the height's already on here. You did 4 heights, 20, 40, 60, 80. And the IMAs and AMAs should be between 1 and 6 roughly. So if you're plotting one of these, this is 2, 3, 4, 5, 6. And in between, if you have 5, this is like 5.2, 5.4, 5.6, 5.8, and 6. So these are 0.2 in between here. Each block's 0.2. If you have 6.1, you can kind of go, just a little above the 6. So anyway, you'll have 4 points. I'm just going to throw some numbers on here. So you put the 4 points on here someplace, wherever they are. I'm just throwing dots on here for you, really. And then I want you to connect, just kind of connect them with a line here to show. You might label that IMA, and then you can draw another one on here for the dots for the AMA, which could be all down here someplace. I have no idea. You just have to plot them. And you can draw the line, and then label that as well. And that could be the AMA. And put your name on that and turn that in. All right, guys, good luck.